Welcome to the Digital Electronics and Microprocessor video lecture class. Today we are going to discuss about the topic 6 of 8-bit microprocessor, that is interfacing and support chips. So, first is basic interfacing concept, memory mapping and input-output mapping. So, interface is a path for communication between two components. Interfaces is of two types, memory interface, and input-output interfaces. So memory mapped I/O is, in this case, every bus in common due in this case every bus is common due to which the same set of instructions pass from memory and input-output device. Hence, we manipulate input-output same as memory and both have same address space, due to which addressing capability of memory becomes less because some part is occupied by the input-output device. Next is I/O mapping, that is input-output device mapping. The technique used primarily in microprocessing whereby peripheral devices are interfaced to a processor whose architecture supports input and output instructions. An I/O map device is assigned one or more of the processor, input-output port addresses, and data and status information are transferred between the processor and the peripheral device using the processor's input and output instructions. So next is difference between memory map input-output interfacing, I/O map I/O interfacing. So memory map I/O interfacing is the input-output devices and memory both are treated as memory, but in I/O map I/O interfacing, the I/O devices are treated as I/O devices and the memory is treated as memory. In memory mapped I/O interfacing, the I/O devices are provided with 16-bit address values in 8085. But in I/O mapped I/O interfacing, the I/O devices are provided with 8-bit address values in 8085 microprocessor. Next, in memory mapped I/O interfacing, the interface devices are accessed by the memory read or memory write cycle. But in I/O mapped I/O interfacing, the interface devices are accessed by the input-output read or input-output write cycle. Then, in memory mapped I/O interfacing, the peripherals or the input-output ports are treated as memory locations. Thus, all the instructions related to the memory can be utilized for the data exchange between the processor and the input-output device. In I/O mapped I/O interfacing, only the in and the out instructions can be put to use for transferring information between the I/O device and the processor. In memory mapped I/O interfacing, in the memory mapped port, the information data can be moved to the I/O devices from any register to vice versa. But in I/O mapped port, the information write can be moved around between the port and the accumulator. Next is functional block diagram of programmable peripheral interface Intel, that is 8255. So PCI or 8255 is a general purpose programmable input-output device designed to interface the CPU with its outside world such as ADC, DAC, keyboard, etc. So we can program it according to the given condition. It can be used with almost any microprocessor. It consists of 3 8-bit bidirectional input-output ports, that is port A, port B and port C. assign different ports as input or output functions. So here two group control are present, that is group A control and group B control. One data bus buffer is present. So if it takes the value that is D0 to D7, the data bus is bidirectional. The read-write control logic is present. So it is involves the signal that is RD bar, doubler bar, A1, A0 and B7. All are connected to this read-write control logic. Here group A port A and group A port C are under the group A control. Group B port C and group B port B are under the group B control. So this is the block diagram of a programmable peripheral interface, that is 8255. It consists of 40 pins and operates in plus 5 volt regulated power supply. Here port C is further divided into two 4-bit ports, that is port C lower and port C upper. And port C can work in either BSR, that is bit set reset mode, or in mode 0 of input output mode of 8255. Here port B can work in either mode or in mode 0 or mode 1 of input output mode. Port A can work either in mode 0, mode 1 or mode 2 of input output mode. So it has two control group A and control group B. Control group A consists of port A and port C upper, and control group B consists of port C lower and port B. So depending upon the value is CS, A1 and A0, we can select different ports in different modes as input output function of VSR. This is done by writing a suitable bar in control register. So the table is given below, that is CS bar, A1, A0, then selection and address. If CS0 is 0, CS stands for control status bar, that is CS bar. So when CS bar is 0, A10 and A00, at that time the port selection is A, that is port A, and the address is 80H. 80H is the address of port A. Similarly, when CS bar is 0, A1 is 0 and A0 is 1, then the port selection is port B, and the address of port B is 81H. Then if CS bar is 0, A1 is 1, A0 is 0, then the port selection is port C, and the address is 82H. The address of port C is 82H. Then if CS bar is 0, A1 is 1, A0 is 1, then the selection is control register, and the address of control register is 83H. Next, if CS bar is 1, A1 and A0 it does not exist, then the selection is no selection, and here no address is present. Then this set reset mode, that is BSR mode is MSP of control bar D7 is 0, PPI works in BSR mode. In this mode, only 4 C bits are used for set or reset. So here is the control register in this BSR mode. Here the D7 bit is 0. Then then D5, D4, D5 and D6 bits that does not exist. On D0 bit, if it is 0 then it is reset, and if it is 1 then the control register is set. Then D1, D2 and D3 bits are used for 4-bit numbers. Then input output mode is MSB of control bar, D7 is 1, then PPI works in input output mode. This is further divided into D modes. So first, mode selection of port A, that is if it is 00 then N0 mode, if it is 01 then N1 mode, and if it is 1 plus it is N2 mode for input output function. Then if input is 1 then the input output function of port C occurs is activated. Then mode selection of port B is N0, if it is 0 then it is N0 mode, and if it is 1 it is N1 mode. So this is the input output mode of PPI. So mode 0 is, in this mode all the 3 ports, port A, B, C, can work as simple input function or simple output function. In this mode there is no interrupt handling capacity. But in mode 1, handset IO mode or stop IO mode, in this mode either port A or port B can work as simple input port or simple output port. And port C bits are used for handset signals before actual data transmission. It has interrupt handling capacity and input and output are latched. For example, a CPU wants to transfer data to a printer. In this case, since speed of processor is very fast, so it is compared to relatively slow printer. So before actual data transfer, it will send handset signals to the printer for synchronization of the speed of the CPU and the peripherals. Then mode 2 is bidirectional data bus. So in this, it is known as bidirectional data bus mode. So in this mode, only port A works and port B can work either in mode 0 or mode 1. So 6-bit ports C are used as handset signals. It also has interrupt handling capacity. So this is the diagram. This CPU, this printer. So here 4 lines are used. One is data line, that is D0 to D7. Second is STB glass, and third one is STK, and fourth one is DG. So this is all about 8255 PPI. Then 7-segment LED display. So 7-segment LED display, I will discuss it in the next class. Thank you.